Hey, it's Mr. Estrada here, and our learning target for this video is I can prove if a right triangle is a right triangle based on the lengths of its sides. And the key words here are lengths of its sides because we have done this in the past with the slopes of the sides, not the lengths of the sides. So if you remember, let's make some recollection here. Remember how you can prove a right triangle on the coordinate plane by looking at the slopes of the sides? So for example, if I wanted to prove that this was a right triangle, I could find the slopes of BC and CA, and the slopes would be negative reciprocals, and that would mean that angle C is 90 degrees because BC is perpendicular to CA, and perpendicular lines make 90-degree angles. So, you could prove this is a right triangle by looking at the slopes, and then you could write something like this. You could say triangle ABC below is a right triangle because angle C is 90 degrees since BC is perpendicular to CA due to the slopes being negative reciprocals. And that should be a period there, not a comma. So remember how you could do that? Prove a right triangle like that? Well, it turns out that there is another way to prove triangle ABC is a right triangle. And I want to show you that way. Right triangles satisfy the Pythagorean theorem. So we could demonstrate if a triangle is a right triangle by showing that the lengths of the sides satisfy the Pythagorean theorem. So to do this, we will need to find the lengths of each of the sides. So we will need to find the length of BC. We will need to find the length of BA or AB, and we will need to find the length or distance of AC. So I'm going to pause the video and I'm going to go ahead and do that right now. Alright, so I'm back. There are the lengths. I did the distance formula 3 times to find them. And I got BC is 5, so the length of BC is 5. Whoops. Where'd my triangle go? Okay, there it is. Let's bring all that stuff back. I got the length of AC as 5 as well. So it actually turns out that this is also an isosceles triangle, but that's not really important right now. We're not focusing on that. And it says AB is radical 50. What I do want to focus on is how do these lengths show that it's a right triangle? I mean, we know it's a right triangle, right? Obviously, we proved it already with the slopes, but we can also prove it with the lengths of the sides. Well, remember, right triangles satisfy a squared plus b squared equals c squared. So we know that c is the hypotenuse, so this is our c here. So we could show that these lengths satisfy the Pythagorean theorem. So let's go ahead and do that. So 5 squared, so I'm gonna make BCA. So I'm gonna write A over here. Let's bring that back. And I'm going to make ACB, and then this is the hypotenuse, so that has to be C. So I got 5 squared plus 5 squared equals radical 50 squared. Now, let's see if this satisfies the Pythagorean theorem. 5 squared is 25. Radical 50 squared is just 50. If you square a radical, you get whatever's under it. 25 plus 25 is 50. 50 equals 50. So there you have it. Triangle ABC satisfies the sides, I'm actually gonna write it down. So you could say the sides of triangle ABC satisfy the Pythagorean theorem. There it is. So that also makes it a right triangle. All right? Okay, let's talk a little bit more about this. If a triangle is a right triangle, then the lengths of the sides satisfy a squared plus b squared equals c squared. If a triangle's sides, apostrophe s, because it's possessive, if a triangle's sides do not satisfy the Pythagorean theorem, then it is not a right triangle. So let's apply this to some other types of problems. Here it says, which of the following sets of numbers could represent the three sides of a right triangle? So we're going to have to check which one of these sets of numbers satisfies the Pythagorean theorem. So let's start with choice A. I'm going to call this choice A, this will be choice B, this will be choice C, and this will be choice D. So for choice A, 16 squared plus 31 squared, does it equal 34 squared? We got to check. For choice B, 39 squared plus 51 squared, does it equal 65 squared? We got to check, right? We have to check for this one. So I'll put a question mark there. I'll put a question mark for this one as well. For choice C, 25 squared plus 60 squared, does it equal 65 squared? We got to check. And choice D, 20 squared plus 21 squared, does it equal 28 squared? We got to check. Only one of these can satisfy the Pythagorean theorem. We have to see which one. Okay, so I went ahead and I checked to see which set of numbers satisfies the Pythagorean theorem. So you can see that in choice A, 16 squared is 256, 31 squared is 961, 34 squared is 1156. If these measurements truly represent a right triangle, 256 plus 961 should equal c squared, and they don't when you add them up. So it's not a right triangle. The choice that satisfies the Pythagorean theorem is choice C. 25 squared is 625, 60 squared is 3600, 65 squared is 4225. 625 plus 3600 will give you 4225. So this satisfies the Pythagorean theorem. So the answer is choice C. Let's look at another example. It says, which set of numbers could not represent the lengths of the sides of a right triangle? So again, we have to check which one of these will not. So this time is will not satisfy the Pythagorean theorem. So let's begin with choice 1. 1 squared plus 3 squared, does that equal radical 10 squared? 1 squared is 1, 3 squared is 9. Radical 10 squared, you're going to lose the radical and get whatever's under it, you get 10. 1 plus 9 is 10, so 10 does equal 10. So this does satisfy the Pythagorean theorem. So these lengths could represent the sides of a right triangle. We're looking for the one that could not represent the lengths of a right triangle. So let's try choice 2. Choice 2 says 2 squared plus 3 squared, set that equal to 4 squared. 2 squared is 4, 3 squared is 9, 4 squared is 16. 4 plus 9 is 13. 13 does not equal 16, so this cannot be a right triangle. So the answer is choice 2. Choice 2 is the answer. These measurements could not represent a right triangle. Okay, so to summarize, remember, if a triangle is a right triangle, then the lengths of the sides satisfy the Pythagorean theorem. If a triangle's sides do not satisfy the Pythagorean theorem, then it's not a right triangle. I hope this helps. Take care.